Now, how do we measure? Okay, let's start with the control chart. That is a data logging organized method that allows us to focus on the phenomena that affects us the most. For example, here we have 3 machines, and in these machines an error presents itself depending on the hour. Now, if an error happens, we will put a simple tick. Now check out this immediately. You can see when we document it this way, we can see that most of our errors happen when? In the last 8 hours of a work shift and at the beginning. So what does this tell you? That something is going on with those machines. First as they warm up, and then when they are getting tired towards the end of the shift. So just by doing this simple graph, this simple control chart, we have some elements to act. Now we put numbers to it, and it's even easier to see which machine has more errors. Machine A. But machine C has more errors towards the end of the shift. Perhaps because it's getting hot, sometimes because the oil has run down low, I don't know. But now I have elements to be able to go and find out and start reducing those errors. Then we have the scatter plot. This helps us to analyze one value against the other. And here the important thing with the scatter plot is to identify the correlation. Remember, there were 4 possible correlation values. And correlation does not imply causation. These are things that you must learn by heart. Then we have the cause-effect diagram, also known as Ishikawa diagrams or Fishbone diagrams. They allow us to identify graphically the causes of a situation. Actually, it's the direct lineage for the results tree that we have seen when we were talking about operations programming. How do they work? Well, first we just put a line that represents our process, and then we start to identify some of the problems. And those problems, in turn, have identifiable causes for themselves also. We do that for all our branches, and we finally have a cause-effect diagram. Perhaps we don't know really out of the blue what is the cause for this problem, but if we go one by one, working and identifying each branch like this, then we can find every single detail and we can start correcting them. Next, we have the Pareto Chart, which allows us to identify the problems in descending order of frequency. It allows us to focus on the most important things. So we can see here that the frequency, for example, for error A is the most important, and that's where we should concentrate ourselves. Then we have a flowchart. In the case of a flowchart, it's a graphic describing the steps in a process, and as a recommendation, always identify actors and try to keep things very clear, even though they might be a headache for you at the moment of drawing it. So always try to keep your yeses in the same direction and the no's in the same direction when you have a decision point. Always try to keep your different organizations or actors or departments separated. So a simple flowchart would be more or less like this. That's a really hand-drawn, very quickly given flowchart. Now if you want to do a more complete flowchart, you have this one, where I have here every single area has its own section. All our decision branches always give the yes in one part, the no in the other, if I can. And it flows from top to bottom. And always we have all this data. What is the process? When was it developed? For which area? Who did it? The identifier for the process, and who approved it. Then we can continue on, for example, to a histogram. That's another graph that shows us the distribution of the frequency of the selected variables. And then we go on to the statistical control process. Now this is something that's a very strong tool. This is the basis of modern quality. And let's look at it part by part. First we define our target value. We define an upper control limit, UCL, and a lower control limit. These are our points as they happen. So, what is going on with these values? Okay, all these that are inside our control limits are acceptable. They are inside our range. The other two, they are out of range. So these are not acceptable. Those two are the ones that we go and investigate what is going on in order to be able to eliminate them and make them all fall inside the control limit. Here, for example, I am putting a process, an example of a process, and as you can see, the specifications are in red. My control limits are well within the specifications. Nevertheless, I identify immediately 3 points that are outside my control limits, even though they are within the specifications. Those 3 points demand my attention so as to have my process working exactly as I wanted. Our lesson will continue in the next video.